In this video, I'm going to show you how you multiply two matrices together. So we're given the matrices matrix A and matrix B. Two matrices can only be multiplied together if the columns of the first matrix, so which we've called N, equal the rows of the second matrix, we've called that value P. So we can see here the columns of matrix A must equate to the row of matrix B. The resulting matrix after multiplication will have size of the rows in the first matrix times the column in the second. So let's actually see this in action with some proper matrices to make sense of it. So we've got matrices A, B and C as follows. Matrix A is a 2 by 3 matrix. Matrix B is a 3 by 2 and matrix C is a 2 by 2. So we're going to try and find the multiplication of matrix A times matrix B. So to check this, we're going to make sure that when we write the order of each matrix, that the column of the first one equals the row of the second, and it does. And the resulting matrix we're going to get is going to be a 2 by 2 matrix. So we know that after we multiply these together, our answer will fit in a 2 by 2 matrix. So let's see this in action. We've got matrix A, 5, 3, 1, 2, 1, negative 2, multiplying by matrix B, 2, 1, negative 1, 3, 0, 1. Okay. So what we're actually going to do now is we're going to take the first column of matrix B and multiply this onto the first row of matrix A. So we're actually going to say 5 times 2, 10, plus negative 1 times 3, negative 3, and 0 times 1 is 0. And we're going to add them on. So we're going to multiply, flip that column up and multiply those corresponding elements. Now we're going to do the same with the second row. So that column, 2, negative 1, 0, is going to be multiplied onto 2, 1 and negative 2. So 2 times 2 is 4, plus negative 1 times 1 is negative 1, plus 0 times negative 2 is 0. Okay, now let's take that second column, and again we're going to multiply it onto that first row, each corresponding element. So we've got 1 times 5 is 5, plus 3 times 3 is 9, and 1 times 1 is 1. And then that second column onto the second row, 1 times 2 is 2, plus 3 times 1 is 3, plus 1 times negative 2 is negative 2. And then adding these together, we've got 10 and negative 3, which is 7. And then we've got 5 plus 9, which is 14, plus 1, 15. 4 take 1 is 3. 2 and 3 and negative 2 leaves 3. So AB multiplied together leaves us with a 2 by 2 matrix, 7, 15, 3, 3. So we can see here that when I do the product AB, that means that B is pre-multiplied by A because the A is first, or we could say that matrix A is post-multiplied by B because B was the second matrix in the multiplication. We can actually use our class pad to input matrices using keyboard math 2, and there's a lovely video at classpad.com.au showing this, and we'll look at that together in class as a practice on how to use our class pad. So multiplying by a 0 matrix is where we multiply where every element is 0. So it doesn't matter what size the matrix is, all the elements are 0, and that's denoted by a bold letter O. So let's say we had matrix A, which we had 5, 3, 1, 2, 1, negative 2, and we multiplied it by a 0 matrix. Now matrix A is a 2 by 3, so we need to make sure our 0 matrix is going to be a 3 by something. I'm going to make it a 3 by 1. These need to equate for them to multiply. and our resulting matrix is going to be a 2 by 1. So this column is going to be multiplied onto the first row and then onto the second row. And that's going to give us our 2 by 1. We're going to get 5 times 0 plus 3 times 0 plus 1 times 0, which will give us 0. And 2 times 0, 1 times 0, negative 2 times 0 is 0. And we end up with a 2 by 1 resulting 0 matrix. So just like numbers, when you multiply any number by 0, you get 0. Same with a matrix. However, if we think about this another way, does it always have to be a 0 matrix to end up with a solution that's a 0 matrix? Do we always have to multiply by a 0 matrix? So what we're going to see here is that if we have two numbers, x and y, that multiply that gives 0, then we know that one of them or both of them has to be 0. But with matrices, this is not always the case. We know if we multiply by a 0 matrix, we're going to get a 0 matrix solution. But sometimes we're going to be multiplying non-zero matrices and we're going to get a 0 matrix. So let's see that here by multiplying G and H. They're both 2 by 2 matrices, so we can multiply them together and the result will be a 2 by 2. So we're going to have 2, 1, 2, 1 multiplied by 2, 1, negative 4, negative 2. So again, we're going to take that column and multiply that first. So we're going to get 2 times 2 is 4 and negative 4 times 1 is negative 4. Onto the second row, 2 times 2 is 4 and negative 4 times 1 is negative 4. Onto our second column, onto our rows. 1 times 2 is 2 and 1 times negative 2 is negative 2. 1 times 2 is 2 and negative 2 times 1 is also negative 2. And when we equate this, we get a 2 by 2 matrix that is a 0 matrix. So in this case, the matrices that we start with don't have to be a 0 matrix to end up with that solution. Now the identity matrix, as we've heard before, is a square matrix where the diagonals are 1s and every other element is a 0. Let's see what happens when we multiply a matrix by an identity. So let's use matrix B. We've got 2, 1, negative 1, 3, 0, 1, multiplied by the identity or unit matrix as a 2 by 2. Now the size of matrix B is a 3 by 2 and the identity is a 2 by 2, which means, yes, we can multiply them and the result will be a 3 by 2. So 3 rows and 2 columns, the same size as matrix B. So again, this column is going to be multiplied onto each row. So 1 times 2 is 2 and 0 times 1 is 0, so that will give us a 2. And then we're going to multiply that onto the next row. 1 times negative 1 is negative 1 and 0 times 3 is 0. And then onto the next row, 1 times 0 is 0 and 1 times 0 is 0. Okay, next column onto each of these rows. 0 times 2 is 0 and 1 times 1 is 1. 0 times negative 1 is 0 plus 1 times 3 is 3. And 0 times 0 plus 1 times 1 is 1. And what we realise here, if we look back at what we started with to what our solution is, that multiplying by the identity matrix gives us the matrix itself, matrix B. So multiplying by the identity matrix produces the same matrix. Okay, so let's see multiplication in action one more time. So let's go back to our earlier matrices. Let's multiply matrix B and matrix C. So thinking about their size, is it possible? Well, we've got a 3 by 2 and a 2 by 2. So yes, it is possible, and we'll have a 3 by 2 as a result. So we've got 2, 1, negative 1, 3, 0, 1 being multiplied by matrix C, which is 2, 1, negative 3, 2. So again, that column is being multiplied on each row. So 2 times 2 is 4, plus negative 3 will leave 1. 2 times negative 1 is negative 2. Adding on negative 9 will give us negative 11. 2 times 0 is 0, and negative 3 times 1 leaves negative 3. So now it's the second column being multiplied onto each row. 1 times 2 is 2, plus 2 times 1 is 2, so 2 and 2 is 4. 1 times negative 1 is negative 1, plus 2 lots of 3 is 6, so that will give us 5. 1 times 0 is 0, and 2 times 1 is 2. So that's our resulting matrix. Now we want to pre-multiply matrix A by C, which means we're going to put C before A. So we've got some order here. So that's going to be 2, 1, negative 3, 2, multiplied by, whoops, that's a little bit long, matrix A, which is 5, 3, 1, 2, 1, negative 2. Just checking, we've got a 2 by 2 and a 2 by 3. So yes, we can multiply these and we have our resulting matrix as a 2 by 3, same size as A. So again, column onto each row. 5 2s are 10, plus 2 1s are 2, so we get 12. 5 times negative 3 is negative 15, plus 2 times 2 is 4, so negative 15 plus 4 is negative 11. Next column onto the rows. 3 times 2 is 6, plus 1 times 1 will make 7. 3 times negative 3 is negative 9, plus 1 times 2 is 2. Negative 9 plus 2 is negative 7. And 1 times 2 is 2, plus negative 2 will be the 0. 1 times negative 3 is negative 3. Take another 4 will leave us with negative 7. And that's how we multiply matrices. So now I'd like you to pause the video and have a go at the following couple of questions. At least have a go at question number 1 before you check your solutions.